All right, thank you very much. First, let me say what a pleasure it is to be here at PenTest HackFest. It's been a pleasure watching all the talks and engaging with some of my previous colleagues, many whom I haven't seen in several years. So I'm excited to share this with you. This is Attack and Defend, leveraging AWS Serverless technology for end-to-end C2. Now, the premise of this talk is pretty straightforward. We're going to explore what exactly is Serverless C2. How does it work, and why is this a threat we should be aware of? My name is Michael Long. I'm a senior security engineer at Amazon Web Services. So this is a fairly dense talk, so I want to kind of break down our roadmap, those different topics that we're going to be exploring. As we get started, we're first going to discuss a typical C2 infrastructure, and that's going to give us a common baseline from which to compare and better understand serverless C2. We'll then provide some foundational information about serverless architecture, and that will lead into a discussion about examples of serverless activity observed in the wild. Now, those 3 bullet points are effectively laying foundation for the more interesting content that will follow. So midway through the talk, we're going to get into how does serverless C2 work, how do we model it, and what are some approaches for detecting and mitigating it within our environments. So at the end of this talk, you'll have a strong understanding of serverless C2, and you'll be equipped with some resources that can enable you to research and better understand this topic within your own environment. So quick introduction. Again, my name is Michael, security engineer at Amazon Web Services. I'll share with you that I'm a former MITRE employee. I worked on the attack framework and did a lot of adversary emulation work, also former US Army. Beyond that, I work under the SANS Master's Program as a faculty research advisor. So shout out to any current or previous students under the SANS Master's Program. And like those students, I too am a student. I'm working on my PhD at Dakota State University. And when my schedule allows for it, I like to get out and volunteer, get my hands dirty. This particular photo was taken at Dangerfield Island, which coincidentally is about 7 minutes away from this venue traveling south by car. Anyways, we're here to talk about command and control. So I fully expect most of the people in this room and those watching online, you know what command and control is, but I want to level set for those who may be new to industry or that don't often work in this space. So to quote MITRE ATT&CK, command and control consists of those techniques an adversary may use to communicate with systems under their control within a victim network. So stated simply, it could be deploying a simple reverse shell in a network environment. It phones home to a control server over HTTPS or some other protocol. Likewise, it could be a bind shell type architecture where maybe you log in directly to a target system, perhaps using compromised credentials over SSH or similar protocols. So on this slide, I share with you a typical external command and control architecture. This was based on the Cobalt Strike C2 specification. Now, essentially the way this works is if you're an attacker, you're going to find some way to deploy malicious code into a target environment. It could be via spear phishing, social engineering, assume breach, whatever it is, you get malicious code inside the target environment. At some point, that code is going to phone home, oftentimes to one or more redirectors. Those redirectors will then forward that communications to your designated control server. It's from that control server that an attacker can log in and issue commands to ultimately manipulate and control victim systems within the target network. Now, this is a very typical C2 architecture. I've certainly used this on engagements in the past. I do want to acknowledge the fact that variations exist. For example, if you're doing engagements that involve physical access, wireless, removable media, or valid accounts, it alters how this diagram looks. But for the purposes of this discussion, this is kind of our baseline that we're going to use as we start to explore serverless command and control. Now, one last key point I want to offer on this slide is that effectively deploying C2 infrastructure is hard work. Now, let me expound on that. Whenever we're trying to deploy command and control infrastructure, there's a laundry list of activities we have to do. First, we have to figure out provisioning. Whether it's a physical or a virtual server, we have to have a box somewhere from which we can install our tools, our capabilities in order to run our engagements. Next, we have to configure an OS. In some cases, you're manually installing an operating system, clicking next, 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 install. Once you have your operating system, you have to configure your application software. So it's everything from your basic utilities, Apache web servers, any databases, setting up SSH. It's also your red team tools and capabilities, for example, installing Cobalt Strike and by extension Java. We're still not done. We have to do user account management. We don't want anybody just logging into our control infrastructure and doing what they want in it. So we got to have a secure way of allowing our red team operators to log in, also logging their behavior or their activities for accountability purposes. We're still not done. There's hardening. It's not enough to have SSH. You got to make sure that the root account isn't enabled. You want to make sure that it's not easy for unauthorized users to interact with your infrastructure. We're still not done. This is getting kind of old. We still need to get SSL and TLS certificates. We got to register domain names. And then there's the matter of reputation. If our infrastructure is too new, it may be disallowed in certain environments. So all of these activities I've outlined, I've been there and I've done it manually. Now, it's really good for a new engineer to do these things manually end to end because you learn a tremendous amount of information, but you're going to quickly outgrow that. And going forward, you want to start incorporating automation. A lot of red teamers initially saw this problem incorporating various shell scripts, either in Bash or in PowerShell. If your complexity starts to grow beyond that, you might start incorporating infrastructure as code type capabilities, which I'll share with you a little bit later in this talk. Now, all of these activities, I'm going to kind of refer to that as our C2 infrastructure chore list. And the bottom line here is that going through these chores manually is error prone and it's tedious. And it's because of this that I wanted to explore what are some capabilities of serverless technologies that can negate the need to address some of these chores here. So at this point, I'm going to give you some foundational information about serverless architecture. Now, essentially, serverless architecture allows you to build and run applications without having to manage the underlying infrastructure. So in my experience, all of these things here can often be completely resolved with serverless technology. And the benefit for you is it frees you up to focus on your specific problem, which in our case is command and control. Now, one of the serverless technologies we're going to talk about as we get into serverless command and control is AWS Lambda. Now, if you're unfamiliar, AWS Lambda is an event-driven serverless computing platform provided by AWS. And essentially the way it works is you're going to write some application code. You can write your application code locally, or you could do it in the AWS Web UI console. You write your code, you then upload it to AWS Lambda. And it's from there that you can execute the code. You can either do it in the web console UI, you can do it using the AWS CLI, or you could execute your code using the AWS SDK. The AWS SDK is of particular interest to us because later on we're going to use that both for our C2 agent and also for our operator client. One last thing I'll share with you regarding AWS Lambda. It can be cheaper than running a dedicated server 24/7. And the reason for this is pretty straightforward. With serverless technologies in general, you usually only pay for the compute time you consume. So you might have a Lambda function that gets invoked 100 times a day. Compare that to a dedicated server, which is probably running idle 90% of the time. Okay, so we've given you some foundational information about command and control. We've also given you some foundational information about serverless technology. What I'd like to do now is share with you examples of serverless C2 in the wild. Now, there's a number of blogs from various sources. TrustedSec is one of the more prominent ones. This blog here by Adam Chester describes how to use AWS Lambda for Cobalt Strike beacon redirection. There's another TrustedSec blog that demonstrates how to use Cobalt Strike beacon redirection with Azure serverless functions. So one of the key takeaways here is what I'm going to share with you is not by any means limited to AWS. This is something that affects all cloud providers. There's another article from Rhino Security Labs. And in this article, they offer a proof of concept C2 using primarily AWS S3, which is cloud storage. There's another useful tool by Hacker Rob called the Serverless C2 framework. I haven't actually run the tool, so I can't guarantee that it works. I did go through the code, and it's pretty interesting. It's actually very closely aligned with some of my research goals for this presentation. Now, in light of all this activity, the MITRE attack framework has recently codified serverless threats with some new TTPs. We have everything from acquiring serverless infrastructure, compromising serverless infrastructure, and then serverless execution. Now, the examples I showed you on the previous slide were largely more in kind of the red team operator space. You could argue that it's a little bit more theoretical, but on this slide, I'm going to share with you a potential real-world example of serverless C2 in the wild. So there's a company called Arista I'm not too familiar with the company, but they did release a blog article about this. In their article, they explicitly state the C2 server was serverless code in the Azure cloud. And I should add that this article pertained to an intrusion observed in one of their customer environments. So in their article, they blatantly state the C2 server was serverless code in Azure cloud. They provide a supporting screenshot. Not sure if you can see that too clearly. But that was essentially the extent of the procedure level detail that they offered explaining this behavior. Now, I'm kind of a skeptical engineer. It wasn't really enough for me to say, yes, that is serverless C2. I'll kind of give them the benefit of the doubt, though. They likely withhold customer information in order to safeguard their customer data. Whether you believe this article or not, I think Arista accurately describes the threat posed by serverless C2. And they state, this is terrifying from a threat detection and hunting perspective because the C2 traffic has the same hosting, certificate, and server characteristics as the vast majority of traffic to and from most enterprises. So when we kind of sum up some of the key points that we've discussed so far, one is that serverless technology can remove a lot of operational overhead associated with traditional C2. And second, and perhaps more important, serverless C2 is very good at blending in with legitimate enterprise traffic, which makes it very difficult for your network defenders to identify and respond to this behavior. Okay, so I kind of alluded to some of the problems thus far. Now I'm going to restate them because we're going to start shifting gears from what and why serverless C2 matters to how does it actually work? How do you operationalize it in the context of your engagements? So we established that traditional C2 architecture entails significant overhead. Think back to that chore list that I shared with you. We also established that serverless C2 is enticing to adversaries because it's hard to distinguish malicious serverless activity from legitimate. Additional problems include limited public threat intelligence for serverless C2 threats, and also limited tooling for modeling serverless C2 threats. And a lot of these problems are related. I think when we have more tooling, we're going to have more threat intelligence because we're going to start building the detection engineering that can allow us to identify this in the wild. So in light of all these problems, I kind of set out on my own independent research objectives to better understand this problem and come up with some ways of modeling serverless C2 activity. So in order to do this, one of my key goals was create a no-kidding working end-to-end serverless C2 framework based on AWS services. Notionally, you could probably build something like this that's server provider agnostic, but I wanted to go deep with a single provider so I could focus on those details and perhaps at a later time expand to other cloud providers. I also wanted to understand benefits and trade-offs of serverless C2, both in terms of the developer experience as well as the red team operator experience. After that, I wanted to characterize the C2 activity from a target to AWS API gateway. And it's okay if you don't fully understand what that is. I've got a slide later on that shows a diagram where exactly that's going to take place. Finally, I wanted to enable follow-on detection and mitigation research so that we can do a better job at trying to detect this threat in the wild. Okay, so methodology was pretty straightforward. Step one was basically build a serverless C2 framework. And I'm going to share with you what that looks like and how it works in a moment. But essentially, it consists of three components. There's a serverless core that's backed entirely by AWS services. There's an operator client, basically the program that a red team operator would use, and then an agent component, which is what would run on an endpoint target. Next, I wanted to deploy this serverless C2 framework using only automated methods. I talked about that operational overhead, that chore list. I'm not interested in adding to that. So I really wanted an infrastructure as code solution to automate this so that my life is easier as well as any other researchers that are trying to study these TTPs. Finally, I studied the serverless C2 behavior from target to API gateway. And I did that using common tools you're likely familiar with, Wireshark, sysinternals, and so on. Okay, so at this time, I'm going to share with you my reference implementation for serverless C2 architecture using AWS technology. Now, as we get started, I'm going to break it down from two perspectives. First, from the perspective of an agent running on a target system, and then from a red team operator who's issuing commands. So if you look at item one, that corresponds to a target system. So consider this a notional target network environment. It's from this point that we deploy an agent. And again, I don't really care how the agent gets there, exploit, spear phishing. The point is that there's malicious code running on a target system. Once you get that agent running, it's going to call back to API gateway designated with node 2. API gateway is basically the entry point for agent traffic into the overall C2 architecture. Now, API gateway is pretty interesting. It operates similar to a bouncer in that if you're unwanted traffic, it's not going to let you in. Likewise, if you're intended agent traffic, it will forward you to the next node within the architecture. I'll also share with you that API gateway has an API key model, which could be just another way of better securing your offensive architecture. So assuming we're dealing with legitimate agent traffic, the next thing that's going to happen is it's going to get forwarded to an agent-facing Lambda. Now notice how there are two Lambdas here, an agent-facing Lambda and an operator-facing Lambda. This was done so that we could basically separate privileged code from untrusted code. In other words, if you're an agent coming from the internet, you probably don't want maximum visibility into all agent sessions. You don't want agents to have the ability to issue tasks to other agents. So by separating our agent and our operator code, we basically separate the access so that only operators could do operator tasks, only agents could do things agents need in order to function. Now, next I bring you to node 4, and this is basically from the perspective of our red team operator. So our red team operator wants to issue commands to our agents. The way this happens is the operator uses a client I call Red Nimbus C2, and or the Red Nimbus C2 client. And I'm going to show you how that works and how to run it in a couple of slides. But essentially, using this client, the operator has direct access to the operator-facing Lambda. Now, one disclaimer there, that access is controlled entirely through AWS authentication infrastructure. So stated differently, when I built this, I didn't have to write any authentication code whatsoever. That is taken care of completely by AWS. And the idea is if you have a valid AWS account and the appropriate permissions for this architecture, then your red team operator can log in and interact with it. But anybody else on the outside cannot. Now, once an operator interacts with the operator-facing Lambda, it's from here that the operator can issue tasks that get stored in S3, and those tasks eventually get issued to agents so that they could then run commands. One other note, observe item 6, CloudWatch. So CloudWatch is our AWS native logging mechanism. And I'm actually really excited about CloudWatch. It gives you maximum visibility into everything happening on the agent side and also on the operator side. So you're going to know everything that's happening. And it just gives you so much visibility that you feel empowered using this architecture. So if you haven't used CloudWatch and you want to get into AWS, I recommend it. You're going to learn a lot. You're going to get a lot of visibility into your different services. Okay, so in the next few slides, I'm actually going to show you how to basically install Red Nimbus C2, how to deploy agents and issue commands. But I do want to offer some disclaimers to help keep you out of trouble in case you're doing this kind of research and testing. So first, my Serverless C2 framework, you're required to build it from source. Now, I make it really, really easy for you, but the reason I require that is so that all forensic artifacts resulting from your use are attributed to your development environment and your AWS account. I don't make public infrastructure just freely available, although I admit that could actually be a really interesting research topic. Another point, by definition, this rides AWS serverless technology. Therefore, you are subject for being billed for your consumption of AWS resources. Now, for what it's worth, I did the entirety of this research and stayed under the free to use tier, but your mileage will vary depending on your load. Other points to stay out of trouble. Make sure you've got explicit written permission to conduct your assessments from the network owners. Make sure you stay in scope and follows your rules of engagement. And lastly, this is important from an AWS perspective. You are responsible for complying with the AWS support policy for penetration testing. If you've never read it, it is very reasonable. At the time of this presentation, they offer 8 different services that you can assess without prior notice. I believe that includes both AWS Lambda and EC2. And otherwise, they're very supportive of other kinds of security testing and exercises. So make sure you read that and then follow it so that you stay out of trouble. Okay, so at this point, I'm going to show you basically how to build, install, and use Red Nimbus C2 to model serverless C2 activity. Now, there are some prerequisites. First, you need to create an AWS account. It kind of goes without saying, but this whole thing relies on AWS, so you need an AWS account. You also need to set up the AWS CLI because that's going to help support authentication to the infrastructure later on. Since we're building from source, there's a number of build dependencies you have to install. If you're a developer, none of these are crazy, but if you're kind of a casual user, you're not familiar with building things from source, this can be a little bit unwieldy. So in light of that, as of yesterday, I just pushed a Docker file where you can, in 3 commands, build a Docker image that has all of this pre-installed and just ready to go. Essentially, it's a Docker build, Docker run, AWS configure, and then you'll satisfy all of these prerequisites. Okay, now we start to get into the fun stuff. So if you want to deploy Red Nimbus C2, this is how it works. First, you're going to clone the repository. And I will add that this whole thing is open source, released under the Apache license. So you're free to take a look at it. You can basically do whatever you want with it. So you clone the repo, you cd into the repo directory, and then you run this command, make deploy. That's based on the GNU make build system. Not everybody likes make files. If you're old school, if you're familiar with building like Unix type software from source, this is often how it's done. I actually like make because it's a really simple project management solution, which is why I chose to use it. But at the very simplest, you run make deploy, and it's going to invoke some scripts behind the scenes to deploy all the infrastructure you need in order to run serverless C2 style activity. I have another option as well, make deploy, where you specify a specific AWS profile. And this could be really handy if you have multiple profiles. So for example, you might have an AWS account limited for work purposes, another one for personal or research purposes. And conceivably, you could use this to deploy unique architecture from one engagement to another. Now, once you deploy, you're going to see a whole bunch of console output for about 1 to 2 minutes. At the very end of that console output, it's going to output a Nimbus C2 agent URL, which you see on this slide right here. This URL is automatically generated by AWS Cloud Development Kit, and this is basically the URL to API Gateway. In other words, this is the URL that your agent is going to call back to. And I'll show you a little bit later on how you give that URL to the agent. Now, kind of a gotcha here. As soon as you clear your screen, you're going to lose that. You're going to forget about it. Later on, you're going to be like, oh, what was that URL? I need it. It is written to a file, so you don't have to worry about losing it. It's there. Okay, so at this point, you've built Red Nimbus C2 from source. You've deployed it by running the make deploy command. Now you're ready to actually start deploying agents and issuing commands. Now, under this repository, I provide a reference agent written in Python. Now, the reason I chose Python was primarily to deter abuse by adversaries, while also enabling legitimate security practitioners to perform this kind of research. You figure with Python malware is generally well understood, generally well mitigated, and there's enough operational issues with it that a serious adversary would most likely not use Python for most intrusions or campaigns. That being said, by being Python, it's really easy to read the source code. And if you wanted to port it to a more operational language like C, C++, Go, C#, it's pretty easy to do so. One other point I'll add is that the agent has no external dependencies. It uses only the Python standard library. So I don't know if anybody here is kind of an avid Python developer, but has anybody here ever used the HTTP requests library? It's nice, right? Have you used the built-in URL lib library? Not as nice as the requests library. So I went to the trouble of doing all this in URL lib so that there are no external dependencies. It was painful for me, but it makes your life easier. You're welcome. All right, so when we're ready to deploy an agent to target, this is how it works. Somehow you put the agent on target. As a simple example, later on, I'll show you that you can just copy and paste it onto your target. Once the agent code is there, this is how you invoke it. You're going to run Python, followed by the agent, and then you could toggle verbose console logging, and then you need to pass it a URL. This API gateway URL corresponds to this URL right here. So that's all you do to deploy the agent. It's going to call back. You're going to get a bunch of console output to kind of see what's going on. After you deploy an agent, you're ready to start issuing commands. To do this, you're going to use the Red Nimbus C2 operator client. This is also written in Python. Unlike the agent, this does have one external dependency. It's basically the AWS SDK Boto3 library. It's really easy to install. Just do pip install requirements.txt. Once you do that, you're going to want to issue some commands. The first one you're going to want to issue is list sessions, and that's going to dump a list of the existing C2 sessions that you have. Once you've got a list of your existing sessions, you can start issuing commands. So in this example, we're running the set task command. We're specifying a session ID, and that session ID is going to be taken from the list sessions command. We're then saying I want to issue a command called exec command. And what that's going to do is it's going to invoke a Python subprocess in order to basically run a shell command. And in this example, we're saying I want to run the hostname command. And this should work both on Linux, macOS, and Windows environments. After you've issued a command, you're going to want to view your task output. And to do this, I use AWS CloudWatch. And this is what it looks like. Using the previous slide as an example, you can see that we issued the exec command task. We issued a shell command of hostname, and you can see the output of that command right here. Now, as of this presentation, I don't actually have this integrated with the Red Nimbus terminal client, but that is a future enhancement I plan on adding. The reason I didn't do it for this is because I got to add a couple extra components to my architecture. I don't want to make it any more complicated than it is as of right now. Okay, so here comes the cool part. Basically, at this point, I kind of showed you how to use Red Nimbus C2, but seeing those commands absent of real context isn't a lot of fun. What I'm going to do now is show you a demo, and you're going to see from end to end what it looks like to deploy an agent, run a command, and see it happen. Okay, so the first thing we're going to do is we're going to deploy an agent to a target system. I'm pulling the agent source code from my GitHub repository. That's the agent source code. I'm going to copy it to my clipboard. And now I'm going to paste the agent source code on my target system. So you can see here I'm opening Notepad. I'm pasting the agent code. I'm saving it to disk. Now we have the agent on our target system. We're now going to execute the agent. So we're running agent.py, verbose console logging. We give it the Red Nimbus URL. So we got a bunch of console activity happening here. I highlighted our session ID, and I pasted it into Notepad for easy reference. Now we're coming over to our operator workstation. I'm going to issue the list sessions command, and we're going to see that previous session ID listed right here. So now that we have our session ID, we can actually issue a command. And here comes the cool part. We're saying I want to issue a command. And we want this to be, we're giving it an argument of doom.exe. And we're specifying the session ID that we got from our agent. So we issue the command. We successfully set the task. Now we're going to switch over to our target system. And look, we've got doom.exe running. This is basically confirmation that we were able to demonstrate end-to-end C2 using exclusively serverless technology. Okay, so that was basically the attack portion of the attack and defend talk. We demonstrated that end-to-end C2 with serverless technology does in fact work. Let's now talk about how do we detect it and how do we mitigate it. Now, I mentioned on a previous slide that for the purposes of this talk, I focused exclusively on studying the traffic from the target system to API gateway. There's some other architecture here that could be of greater interest, but the simple fact is for most organizations, anything that happens here, you either don't have visibility or it's not actionable for you. Instead, this is what is most likely actionable for most organizations, so that's what we're going to focus on. Everything here, that could potentially be a phase 2 research following this talk. Okay, so first we'll start with kind of some endpoint indicators. If we were to study the Red Nimbus agent running under different sysinternals tools, we're going to see kind of expected process execution. Here we see the agent, here we see the command line arguments. One of the key takeaways with this is consider this the bare minimum. If you don't have visibility into this, you don't stand a chance of detecting this kind of activity when it is weaponized to in-memory payloads. Another indicator here is basically seeing network activity. If we're talking about serverless C2, you're most likely going to see network connections to AWS API gateway. So that's what this slide is showing. Now, this is a packet capture of the Red Nimbus C2 activity. Notice that it is fully encrypted, but also notice that you will still see the REST API URL. And that could be useful from an asset inventory perspective. The idea is inventory all of these URLs that you're seeing so that you can start to baseline what is normal, which of these URLs do we own, which of these do we not, and are these services that we expect to be using within our environment. On this slide, I want to show you what the TLS certificate looks like. Key takeaway here is that it is a legitimate, well-formed SSL certificate. If you've been doing detection engineering for a while, sometimes a quick win is to identify self-signed SSL certificates. That is not the case here. You're not going to see any warnings, any red banners. This is a legitimate TLS certificate from Amazon. Another thing I wanted to show was basically name resolution of the API gateway URL. So this is basically the URL for our agent. And when we do an NS lookup on it, we get a number of IP addresses, I assume probably for load balancing. If we do a reverse lookup on these IP addresses, it comes back to CloudFront, which is basically Amazon's content delivery network. So really what this is showing you is there are few observable indicators to help identify this as malicious traffic compared to any traffic that is going to AWS. Okay, so at this point, we've talked about how serverless C2 works. We've talked about some of the different ways that you can detect and observe it in your environment. Let's now start talking about mitigations. So first, asset inventory is critical. Specifically, you need to know the cloud workloads your organization owns and or utilizes. Next, I recommend leveraging allow list technology for both executables and network connections. Now, a common trap with this is basically trying to eat the elephant, trying to deploy allow list technology everywhere. And you'll find that that is exceptionally difficult. Allow list technology can often be labor intense. It takes a lot of work to maintain it and keep it running. A better approach is to try and do it in small chunks. For example, if you've got a group of non-technical users and they're not constantly installing new applications, they could be a good candidate for allow list technology. Your developers, on the other hand, who are always installing things, they'd be kind of a bad candidate for this, at least initially. So when I recommend allow list technology, I also recommend do it in small portions, take baby steps with it, gradually roll it out in your environment. Now, these are some other mitigations. I took these pretty much directly from the attack framework. One is to remove permissions to create, modify, execute serverless resources from users that do not require them. This can help you prevent adversaries from deploying infrastructure like Red Nimbus C2 under your own AWS account. You also want to monitor creation and modification of serverless workloads. That way, if someone does deploy a capability like Red Nimbus C2, you'll have early warning, you could respond to it. And you want to monitor logs generated by serverless C2 workloads for anomalous activity. If you were to look at my CloudWatch logs for Red Nimbus C2, it is completely anomalous. It should definitely freak out any defenders seeing that happening in their environment. Okay, so that brings us to the conclusion. So key takeaways here. One is that serverless C2 removes operational overhead associated with traditional C2 infrastructure. And more importantly, it provides OPSEC benefits in that serverless C2 is very difficult to distinguish from legitimate activity to cloud providers. Now, in light of this, I think we're definitely going to continue seeing serverless C2 activity in the wild. Of particular note is actors using serverless for beacon redirection. I think for most adversaries, that's kind of the path of least resistance. In my case, I basically built a serverless framework from scratch. Most organizations aren't willing to invest all of that effort when they've already invested a lot into existing tooling. So you're going to continue seeing Cobalt Strike beacon redirection with AWS Lambda, Azure Functions, and so on. We're also going to continue seeing attackers compromising serverless workloads. The fact is, serverless workloads are less well understood compared to traditional enterprise security, so it could represent a blind spot that's enticing for adversaries to deploy malicious code. Another key point is that public tooling, CTI, and security research in this space are quite limited. So my call to action for this group is that we need to continue to ethically model serverless threats. We need to build our understanding so that we can advance the state of practice and continue to detect and mitigate serverless C2 threats. If you want to explore additional resources, you can take a look at my bibliography. I also want to express my thanks to the PenTest HackFest facilitators, the advisory board, and my colleagues at AWS have provided a lot of support and reviews of my slides up to this point. One last thing, a copy of my slides and all source code are available at my GitHub repository, so please feel encouraged to take a look at it, and I do welcome contributions from the community.